So my partner in crime is Kirk Arrowwood. He's out of New York City. Apparently the Yankees are in some kind of pennant race for the AL East title or the wild card, so he's not traveling until they win it. The Red Sox play them in a week. I'll be down there with my Manny jersey on and my Pedro jersey and my Pedroia jersey, just literally yelling at most of New York. The best part about this is that the team that's going to knock them out is Canadian. Anybody here Canadian? They're the nicest people. I expect Toronto to say, I'm sorry to the city of New York afterwards. Oh, we're so sorry we knocked you out of the playoffs. So it's probably going to happen. So PernixData, anybody heard of us? Just a straw poll? Besides the one person using us? All right. So the joy of a startup is you do a lot of evangelization. Evangelization is a fancy word for talking to people. So we have a product. We're a startup. Our product was started with one basic problem. That was we thought folks were adding hosts to their ESX environment faster than they were adding storage I/O to their back-end storage. Okay, so for some shops, you know, how many people have 3 ESX hosts at a minimum? How that? How many folks don't have, let me start off with this. How many folks don't have virtualization at all? Haven't done it yet. How many folks have VMware? Anybody with Hyper-V? Oh, brave souls. Anybody new Hyper-V like this third instance, or were they back in 2008 when it first came out and couldn't vMotion? Yeah, you like the new, don't you? It's much better than the old. Anybody with like 8 to 10 hosts of ESX? All right, so when I was at Liberty Mutual, small little insurance company in Boston, I did about 380 ESX hosts there. I was adding them like candy. Literally, people would come to me and say, we have another 34 VMs we need added. I'm like, well, the cluster's full. I got to buy a host. They're like, okay, go buy a host. I was dropping a host in, at least one host a month, if not 2 hosts a month, in 3 different data centers for 18 months I was there. So what we saw host sprawl happening. Host sprawl is this concept that people are putting more and more stuff into a VM, right? Because it's easy to make a VM. It's next, finish. You know, fire up a template, next, finish, pay for the license later, right? Figure out who owns it, figure out if I'm going to charge it back, that kind of thing. It's sort of on-demand computing. What we found, though, was every time they added VMs to this, they basically would change the I/O pattern of the VMs coming to and from the storage array networks, and this caused what we call a massive I/O blender effect. Everybody ever heard this term? It's kind of used a lot. Can't separate the reads from the writes, can't separate the randoms from sequentials, can't separate this VM from that VM. You just see all the I/O gets pushed together. This can saturate fabrics. Anybody got 1 gig on their storage fabric? Just for my own, I love asking questions. How many people here run fiber channel storage for their ESX environment? Fiber channel. Anybody running iSCSI? So a good chunk of iSCSI. NFS. One NFS. There's no other protocols missing. DAS. Anybody got DAS? Direct attached storage? Shared nothing? Okay, cool. Anybody doing CIFS? Hyper-V is probably doing CIFS. You guys doing CIFS off an array or some kind? Okay. All right, so the other thing we found was that storage controllers typically would be exhausted at the controller level, not the disk level. So they had plenty of capacity, they had plenty of space to store more data, but what they were lacking was headroom in the controller to do anything. How many folks bought a SAN in the last 18 months? Anybody buy a brand new storage array? Chris, we'll pick on you, Chris. What did you depreciate it at? 36 months, 48, 60 months? Was it 3, 4, or 5 years?
We tend to keep stuff for 6 or 7.
Yeah, so 72-month depreciation. How many folks can say the word depreciation? Right? I loved the first slide said CFOs and CIOs. Right? We used to only talk to CIOs. Now we talk to the CFO, and you have to worry about CapEx and OpEx and depreciation schedules and 48 months versus 72 and the cost of the goods and NPV, and it's exciting. So we found that people were putting storage in and they wanted to keep it for, say, 60 months, and after 18 months they ran out of headroom. Or anybody here experience high latency on their storage? Maybe have a latency issue that has made you ruin your Saturday to go deal with the fact that one talkie VM is chewing up all the latency on the array? So we went to VMware, and my founders are from VMware. They said that in 2012, 7 out of 10 calls to their technical support center for a VM performance issue were because storage wasn't doing its job. And now we all know that storage may have been purchased, initially sized correctly, but then maybe consumption trends changed, the VM's patterns changed, your mileage may vary on a virtual machine. But at the end of the day, we think storage really sort of started losing its horsepower, and it could have been in the fabric. Anybody ever had a jumbo frame issue on iSCSI? Anybody not had a jumbo frame issue on iSCSI? It's maybe an easier question to ask, right? So a lot of 10 gig, anybody put 10 gig for their iSCSI lately? Upgrade it? Was it an upgrade? You were at 1 gig, now you went to 10? Yeah, isn't it amazing how iSCSI is like, oh, we're fine with 1 gig, but man, look, we're so much better with 10 gig, right? And by the way, Dell happened to acquire a company to sell 10 gig switches. I don't know if Dell's in the room, but Dell has a nice 10 gig switch product now, so that makes sense that the 10 gig would be a good path. So we kind of looked at it and said, well, we're going to put flash in there somewhere. This has to happen, right? Anybody got a phone call? You should look at my all flash array. Anybody ask you that lately? Come on, somebody has to have called you and said, I got an all flash array. You really should check it out. It's worthwhile, right? Well, we looked at this and said, well, there's 3 places to put flash. You can put it in a hybrid file system where you spin disks and have flash together, or you can drop it into a server, or you can drop it into the full storage, an all flash array. And when you look at this, this is what my daughter calls chutes and ladders. I have this printed on my wall. It's kind of fun. It's like 11 by 17. I had it at a trade show once. And she's like, Daddy, what's this? And I'm like, well, what does it look like, sweetie? She goes, it looks like Candyland or chutes and ladders. I said, no, honey, this is enterprise storage. This is what's driving America. And she says, no, Daddy, you put your piece on the board, and she literally took it off the wall and put her pieces on the board. I'm like, yeah, it's a game, right? It's a fun little game. So if you look at how VMware admits data into the kernel, at the ESX layer, ejects it into the HBA, comes out of the HBA, goes into the north side of your switch, pick your switch, iSCSI, fiber channel, whatever it is, comes out the south side, goes into your storage processors, comes out your storage processors, goes into your storage software, comes out your array software, finds the array group, brings the data back. You got 12 steps. This is a graph from EMC from 2009. They said, this is broken. This isn't how storage should work. So what did the all-flash array vendors do? They said, well, we don't really want to fix it. We just want to sell you something new. So we're going to stick flash in the bottom of it. So all the latency from step 1 to step 11, and all you're really doing is improving step 11 to step 12. But give me money. Give me a purchase order, right? So we said, what about this? What if we could put the flash or even use RAM? What if we could use RAM? Everyone has a lot of RAM, right? Who bought the last ESX server in the room? How much RAM was in it? What did you put in there, Chris? 280 gigs of RAM. Anybody remember putting in their first ESX server? I put my first one in, had 32 gigs of RAM in it. And I remember my boss going, do you really need all this RAM? What are you going to do with all this RAM? I'm like, I'm going to use it. It's going to hold lots and lots of VMs. My second ESX server, my second wave of servers was 64 gigs of RAM. When I landed at Liberty, we were 96 gigs of RAM. My second wave of servers was 144. After that was 192. My last servers I purchased were 512 gigs of RAM. Right? We were looking at a terabyte of RAM per host to run SQL, hosted SQL. So when you think about putting it up there, the VM literally can access the flash pretty quickly, right? So we do this because my founding fathers, everyone should have founding fathers, we're in the Northeast, 13 colonies, right? My founding fathers helped create this, the pluggable storage architecture of ESX. It's a little technical for 9 o'clock in the morning, but everybody get what this is? That's vSphere, right? So that's your kernel. You have 2 emulation layers. If anybody sees an Oreo cookie, that's what I see sometimes. You see basically the good white stuff in the middle, the cream. So what happens here is your storage array, SATP, is controlling your HBAs. So when your controller fails over from controller A to controller B, your storage array, the SATP, is keeping you functional while the controller paths are being reorganized, right? We took that and they created this little space in here called the PSP. The PSP is where you'd load EMC power path. The PMC is where you load Equalogix mem. This basically helps you with failover. Well, we said, what if there was a way we could trick it and we could redirect it to RAM? So what this means is your VMDK file, it doesn't move from where it is down here, and the VM doesn't even know we're doing it, but now I can move I/O through, I don't know, 60,000 IOPS on an $800 SSD card. So I could give a SQL server that you were having trouble with 60,000 IOPS on an $800 drive. Meanwhile, your storage vendor is asking you to spend $100,000 with them to do something similar. And you could do this for a couple $100, right? So now, talk about VMware. We work with them. My guys came from VMware. We helped write VMFS, partner validated support program. So we're verified and validated by VMware to work. You don't have to uninstall us. The big thing we're doing, if you remember anything about this whole room, is we decouple storage. We're decoupling performance from capacity. Anybody know their, here's a fun one, talk to your CFO someday. Anybody know their cost per storage metric, the cost per gigabyte, cost per terabyte in the room? Anybody do this analysis? I'll pick on TurboCam because you guys are up the street from me. I live down 125. So anybody come in your office and say, boys, exactly how much money are we spending on cost per terabyte? It could happen, so get that number ahead of time. That way when they come in, you're like, that's $4, we're good, good number. So the average cost for enterprise tier 1 storage is $8,000 a terabyte, okay? Seems high, but it's $4,000 for prod and then $4,000 for a copy of prod. Okay, that's how you get the $8,000, because you count that 1 terabyte protected to get the $8,000. What's a good, is that a good number, $8,000 a terabyte? It's pretty much been around for a long time. It hasn't really improved, right? All flash arrays can take that number into $12,000 to $25,000 a terabyte, right? Low-cost arrays can take that number down to $690 a terabyte, right? Spinning disks, SATA disks, so you have 8 terabyte drives out now. You can do really high capacity arrays. The problem is when you do a high capacity array, you don't get what out of it? Say performance. It's early in the morning, guys. We're gonna get you all riled up. You got coffee. Cogden's donuts are actually cooked with lard. They're the best donuts in the whole wide world. But when you can move performance to the host layer, then I don't have to pay a performance price tag for my SAN. I can pay a capacity price tag for my SAN, which is a lot cheaper. Now, we took this project. There's our founders, Poojan Kumar, Satya Vengani, a bunch of VCs, smart guys wrapped around it. We created our first product, FVP. Our first product basically allows you to take server-side resources. We install a 5 meg plugin inside your ESX host. You put the host in maintenance mode, push the VIB, right? Take the VIB out. Now VIB, Hyper-V, you can't use it. There's no VIBs in Hyper-V yet, but we're working on it. But the idea is then, without any changes to your VMs or any changes to your storage, you can now send reads and writes on anybody's hardware that's supported by vSphere into that piece of flash. Okay? I just want to check for time. What time is it? I don't have a clock in the back, so I can't. What's that?
20 minutes to go.
Oh, good. Left or to go, or what do I have? You got to give me like this. You have like a little card. You have to hold it like 10 minutes.
There you go.
Where is it? No. All right. So the idea here is that when you do so first innovation, non-disruptive. We live inside the kernel. VMs don't even know we're there. Turning us on, turning us off, and we're granular per VM. You set the acceleration policy per virtual machine. If you have vMotion from one host to another, you'll actually be able to access the cache from another environment. So it's distributed across hosts. We piggyback that distribution to accelerate not only reads, we accelerate writes as well. So what that means is if you're accelerating just the reads and you have a SQL database that's 20% read, 80% write, you're only accelerating 20% of that VM's I/O. If you accelerate the reads and the writes, you're accelerating 100% of that I/O. Okay? So the other thing we do is we destage the writes. We make parallel copies to other hosts in the cluster. So if you have a minimum of 3 nodes in the cluster, you can copy the write, we mirror it to another host, and then in the event that that middle host has a problem, we destage it. So we do a lazy write back to your storage. We literally take the pressure off your storage array. Okay? So we scale out. Every time you add a host, you're going to gain IOPS. With 2 hosts and, like I said, a pair of SSDs that are commercially purchased through a VAR, you call up Axis and say, hey, I want to buy some SSDs. So what I'm saying commercially, like, don't buy the personal SSDs. Like, go to your partner, size it with your partner, and get the right type of SSD. Anybody know what DWPD is? Where are my nerds with acronyms? You should all learn one acronym per session. That's my challenge to you today. Come away with one acronym per session. So what's DWPD? We'll pick on the college. Come on, guys. You guys are learners. He's Googling it right now. I know he's Googling it. It's a double IPA sold at Foundation. No, it's durability. It's daily writes per day. So it's how often that SSD can be written to in a given day before the SSD will break. So if you pick a low DWPD SSD and you put it in an enterprise setting, you're going to have problems sooner than later. But if you pick an enterprise DWPD drive, right, daily writes per day, that's your acronym, you'll have good environments. So this is a pretty much an enterprise grade daily writes per day SSD doing about 60,000 IOPS. So on these 2 hosts, with a SAN that can only do 50,000 IOPS, they were capable of doing 120,000 IOPS to the VM. The VM thought it was on a 120,000 IOP array, but it really was putting its working set into 2 SSDs. As you go to 4 hosts, it doubles. As you go to 6 hosts, it triples, right? And meanwhile, your array, you haven't done much more than just make it a capacity box. It's doing fine hosting your VMDK files or your data services like replication and stuff. So we decoupled the data path. You know, Yogi Berra passed away yesterday, right? Great famous catcher, a lot of acronyms. He said, I want the pizza cut up in quarters so I can have 6 pieces. It's a famous, I don't know what it means, but he said it. So we basically feel like the fastest distance is no distance, right? If I don't have to go fetch an I/O from that Candyland map, I don't have to, my application will run faster. So if you've got a SQL VM, VDI VM, Chris, what are we accelerating for you? VDI, SQL, pretty much everything? Yeah, so somebody once said to me, what's the best VM to put on here? I said, any VM that reads and writes data that's important to you, right? That you have a latency or performance problem with. Here's a quick example. Previous to installing, again, this is my demo on a slide, but previous to installing, the purple and the red line, the VM observed and the data store, the latency is locked together. So if the data store latency is high, 15 milliseconds, that can cause performance problems for your end users. Once you install FVP down here, now you see a little bit of RAM start to get consumed. In this case, it was an SSD drive. And the blue line and the purple line start to separate. So once FVP is installed, now the VM's latency is sub 3 milliseconds. We didn't touch your storage. We didn't touch your VM. Didn't load an agent, didn't do anything. We literally installed our software, took as little as 4 gigs of RAM from the host to give it a working set, and we improved the SAN's performance as well. So by moving that top talker to flash, we made the VM faster, which made your customers faster, your internal customers, external customers faster, your business applications faster, but it also made your rest of your VMs faster because your SAN got better. We moved a workload, basically. We rearranged the I/O. Things you'll see after us is the IOPS before, the IOPS after. Everybody has to have another summary slide. I don't know why we have 2, but the big thing here is we're scale out and in nature, right? We're going to scale out across your ESX environment. We have a brag slide. These are a lot of logos. Some of them I think we're not legally allowed to use, so don't tell those people. If anybody here is a lawyer for Starbucks, look away. Look away again, because I forgot to take this one out too. So this example where basically the purple line was their SAN. That's how much I/O was flowing through the environment. And this was a SQL Server VM that once we gave it a little bit of RAM, it went to 7,000 IOPS. It was a 10-fold increase. Okay? And then latency. We had a customer, they were a bank of bears. They hold honey. These guys basically had high latency, so their tellers and loan operators and all their retail bankers were having massive problems. Went to lower latency, it dropped, right? And again, this isn't a storage array. This isn't hardware you have to implement. This is purely software. So we're a software-defined world now. This is telling your virtual machines on a per policy how to make them go faster. So I think I'm time-wise. How am I for time? I'm good. So there you go. You can download our software for free. We released FVP Freedom. It's 128 gig limited. You can only use that for 128 gigs of resources. It's RAM only, and you can only accelerate reads. But you can download that today, use it for free as much as you want. We gave it away. And then if you want that read-write performance or the ability to use SSDs, you can call Access up. They'll set up a POC with you. Our software installs in about 2 hours, right? If you have a VM template for Windows 2008, 2012, you can do it in under an hour. So I had a customer do it literally the other day, and I don't know, they set the record like 28 minutes. They had everything ready to go, so it was pretty fast, but it was pretty quick. Any questions or anything, or I just hand it off to the next person, or what do I do? There you go. What time you got, Sue? What time is it?
9:20. You have till 9:35.
So what did you guys ask? I mean, what do you think? Is that you got a very quick, very fast-talking New Englander, I'm talking to my New England people. I do this presentation in other parts of the country, and I have to literally slow down my speech.
What will we see with the demo using internal RAM versus an SSD card?
So I'll give you a funny story. We had a customer with 2 Dell servers. They were identical. They came from Dell, literally came out of the cardboard, threw them in their rack, put ESX on there, put our software on there, put about 50 VMs on there, 25 per host. And they found that one of the VMs, one of the hosts, was accelerating better than the other. They had moved a SQL Server from one to the other, and when the SQL Server was on host 1, it ran better. When it was on host 2, it ran slower. And it wasn't big, it was just a different number. But they were expecting the same performance on both. They came back to us and said, your software's broken. I said, no, I don't think our software's broken. It's not that complicated. We don't really do it. So let's look at your data. We looked at the data. You can actually look at our software and see the millisecond response time of the acceleration media, so the RAM or SSD. And on one server, it was 0.02 milliseconds, right? So sub-millisecond, sub a tenth of a millisecond was how fast the RAM was processing data for that SQL database. When they went to the other box, it was 0.8 milliseconds, right? So my kids are in 4th and 5th grade. We're doing a lot of decimals. The difference between 0.0 anything and point anything is an order of magnitude, right? Mark, help me with that, right? Math, when you're closer to the point, it's larger. So like 1 millisecond, it's okay. 0.1 millisecond is amazing. 0.01 millisecond, like out of this world, like nanoseconds, right? We went to the server BIOS, looked at it, kept staring at the servers, finally realized they had shipped, servers can come with DIMMs, and they come inside. They had ordered this thing with like 64 gigs of RAM, and instead of putting 16 gig DIMMs in server 1, which they did, they put 8 gig DIMMs in server 2. And they populated all the DIMM banks. When you populate all the DIMM banks, anybody know what happens? Bus speed goes down. How's that for technical? We're talking bus speed at 9 o'clock in the morning. It's fantastic. So the bus speed goes down. They went from 1800 megahertz of bus speed on the first server to 1040 megahertz, or 1060 megahertz on the second server. That megahertz difference was enough to slow down the application. So we simply called up Dell. They shipped the right memory. We replaced the memory. Next thing you know, front-side bus was back to normal. Both VMs were screaming, and it was a server problem. And according to the vendor's like, I just shifted 2 servers. I never realized I had to look at the memory configuration. It's 64 gig, right? It makes it faster. So between memory makes things go very, very fast. And memory handles large block size easily. Anybody here familiar with large block size? Anybody know what large block size is? Yeah, so most I.O. is 4K, right? But what happens when I.O. can't be passed at 4K? It goes to 8K, it goes to 16K, it goes to 32K, 256, 512. If you have an I.O. from your VM passing down at 512, it'll slow down your entire VM farm because your storage array has to address it and deal with it. So RAM is better at large block size. SSDs don't really like it. It'll slow an SSD down. So what we found was RAM was faster than SSD, RAM was better at large block size than SSD, and RAM was it was easier for, say, people who have blades. How many people in the room have blades? How many people have blades versus racks? Blades? Maybe you have racks? Mostly rack mounts? So if you have a blade environment, you're a very small form factor, you have very limited DIMMs, you really can't do much with PCIe cards or even SSD drives. You have to kind of leverage with RAM. So I hope that answered your question about RAM versus SSD. They both work great. It just depends on your working set and what you're trying to accomplish. If you have large block size concerns, stick with RAM. If you have the ability to put SSDs in, there's amazing SSDs out right now. You can get an NVMe drive for just under $2,000 that'll do almost 500,000 IOPS in a 2.5-inch form factor. Anybody else? I know a lot about donuts. Joe, I think I'm good. No, question in the back.
How do you see this as a fit with hyperconvergence?
So it's funny. My boys from Simplicity are here, right? Where's Warren? Is Warren here? If they're not in the room, I can talk better. Okay, let's do it this way. So you have to think about where we live and where hyperconvergence lives, right? Too. So at the end of the day, hyperconvergence is throwing an NFS data store on a software array into the mix, right? So your NFS data store is no longer, the HBAs are logical HBAs now inside the box, right? And your data store is no longer a physical third-party array. It's software storage baked into a controller VM. And what they're doing is instead of using the PSP to kind of redirect I.O., you're redirecting I.O. into what we call a controller VM that's then redirecting it to NFS data stores. So the NFS data stores are primarily made up of what? SSDs and hybrid, or they're all SSD. So back to that question, which you nailed, you set me up perfectly for that. If I'm accelerating with RAM, I can make hyperconverge go faster. So we have customers of most of the hyperconverged vendors that have run into problems with sizing. And again, this isn't a problem with the vendor or the customer. They were told my VMs do 11 IOPS. That's the average IOP. They roll out the product, they buy the hyperconverged, they put it in their data center. Turns out their VMs do 33 IOPS instead. Now they have 3 times the IOPS with a box that was undersized. So what we've done is we actually came in and accelerated a Nutanix platform, because they're not here, right? Nutanix isn't here?
They're not.
Okay, let's pick on them. So we came in and they had a Nutanix platform that was doing about 8,000 IOPS per brick. The customer needed like 17,000 IOPS. They installed us. We went to 24,000 IOPS per brick. Right? And then we had to go call Nutanix up and say, are you going to let this customer use this? And they're like, well, we got to figure that out. And so if we use RAM to accelerate, we can make hyperconverge go faster. If we use RAM to accelerate, we can make anything go faster. Because we're not sending the I/O. Even in hyperconverged, all those queue buffers still exist. They're just condensed into one form factor.